Third important thing, just fill the feedback form immediately after the session so that the issue of certificate will not be a delay. So with this particular insight, we'll hand over the time to Vivian. Over to you, Mr. Vivian. You just give your strong introduction of yourself and the life at Karunya, and then you can start.
Thank you very much, Ranjit sir. So first of all, I would like to thank Macklin sir as well for arranging this session and inviting me. It's a great pleasure to present, to discuss a webinar, to present a webinar on this particular session. So myself, my name is Vivian Dmello. I'm alumni of Karunya. I passed out in the year 2016. Yeah, 2016. So I'm working as an information security officer with one of the oil companies here in Kuwait. And my responsibilities include managing the overall information security of the organization. So it's mainly on the technical as well as the non-technical. That's the compliance part, like ISO 27001 or other compliance requirements. So today we are going to speak about email security, and I'm going to share my screen. Just let me know if you guys can see the screen. And I hope I'm audible to everyone.
Yeah, you are audible. You are audible only. You can just share your screen.
Sure. Okay. Is this screen visible?
Yeah. Visible.
Okay, great. So as the internet is expanding and people are using email, so more number of hackers are trying to target these email services and trying to get access to the email of a user, or trying to modify it, or trying to um, do all the malicious activities with this email. Now, email, we have been using email since the early 90s or early 60s, I would say. But then at that time, security was not such a big concern. And when email, the protocols that email works on, when these protocols were developed, um, these protocols were not developed considering today's scenario when email is actually used as a primary mean of communication for many official activities. Now, since this particular mode of communication has got such a huge importance, hackers have, they try every day to get access to the email accounts. So through this email accounts, they can run their business. And actually, if you guys are familiar with the protocols email work with, so there are three basic protocols that I would be touching today, and those are SMTP, mainly on SMTP, and apart from SMTP, there is POP3 and IMAP. So my focus is purely on email investigation, but then to show you in detail about email investigation or investigating a malicious email, we will first have to go through how the basic email works. So SMTP, like it says, simple mail transfer protocol, is actually meant to be simple. When it was developed, it, in fact, right now, if you have a SMTP server, there are many things you can do with it. You can send phishing emails, you can send spoofed emails. So I'll be taking you through all of these, and I'll help you out. I'll show you how you can investigate and identify these malicious emails. Okay. So we are going to start with basics of how email works, and then we'll go on to how you can identify spoofed emails. Once we finish this, we are going to look at how you can scan malicious emails using sandbox and freely available tools. And it's not just the malicious emails, but then also the hyperlinks, the domains, and other artifacts in the email, how you can extract them. And I will also show you a few of the advanced techniques which are used by email security solution, and how hackers actually bypass this email security solution. So these are the topics that we would be covering at a very high level. So like I said, we'll have a walkthrough on how email technology works, because that will give you a basic understanding of how email works. And then I will introduce something called SPF and DKIM. Um, so SPF and DKIM comes at is used for identity, the domain verification. So um, like I said, in SMTP, there are many weaknesses, and these are a few frameworks that are used to, to mitigate those weaknesses. And we will do a investigation on an email. So I have an email which a colleague of mine had sent, and I will go through and do a header analysis of the email and identify. Uh, I will verify the SPF and DKIM of that email, and I will show you how you can manually verify these details to identify a spoofed email. And finally, we'll see a few advanced techniques by which you can bypass the email security solutions. And then we'll have a question round wherein you can ask me questions if you have. So this is how, okay. So this is how SMTP works. This is just a graphic visualization that I have done over here. So there are many agents over here, right? So let's say it this way: there are two users, Bob and Alice, and both are students of Karunya. And Bob is sending an email to Alice. Now, when Bob sends an email, Bob may use anything called a mail user agent. Now, mail user agent can be anything like Google browser, a Gmail application over the browser, Outlook application over your mobile or your Windows desktop. So anything that will help Bob to interact with the servers to send an email. Now, when Bob sends an email, it goes through many different components, like a mail transfer agent. And a mail transfer agent is nothing but something like a SMTP server. So if you have ever configured an email on your desktop, you always put the server details. So this MTA is basically the server. And Bob will communicate with the MTA, the SMTP server, using a protocol called SMTP. So SMTP is used to send email. And this email, when you send it to a SMTP server, the SMTP forwards it to other SMTP server till the time it reaches its destination. And finally, it reaches the destination called the mail delivery agent. And once it reaches the destination, it stays over there until and unless Alice, that's the user, comes online and accesses her email, and then she can see the emails. So this is just a high level graphical overview. The actual working would be obviously much more complex. And this is just a high level overview. What I want to show is I want you guys to understand where is the weakness. Now, when a attacker wants to attack, wants to send spoofed emails, he will start from the place as where Bob is right now. So he will use the identity of Bob and he will send spoofed emails, or he will send malicious emails trying to impersonate the identity of Bob to Alice. Now, Alice has to verify if the email was actually sent from Bob. So this is where the entire weakness lies, and hackers or malicious adversaries on the internet, they know that this is the weakness in the protocol and we can exploit it. And that is what they exploit to deliver phishing emails into your inbox. So like I said, email or SMTP is completely insecure by default. And that is the reason why we need to use certain add-ons or certain additional configurations on top of these protocols to fill in the gaps which are present. One of the biggest gap in the protocol itself is there's no sender verification required. So for example, if you have your own SMTP server which you configure, you can just take any SMTP server on your local system, maybe a Python SMTP server, and you can configure it. And if you send a email, the SMTP server will not verify where you are sending the email from, whether the domain belongs to you or not. It will just accept it and deliver it to the user you are intending to deliver. So if you are sending email from support@microsoft.com, it will accept it. It won't say that Microsoft.com does not belongs to you. And there is where the entire problem lies, because if the SMTP accepts it, the hackers, they send it. So SMTP accepts it and it gets delivered. They are not encrypted. If the mails are not encrypted, they are vulnerable to disclosure and modification. This modification can be in transit or at rest. In transit is where SMTP host is considered to be compromised, and if the mail is transiting from this SMTP server, if it is compromised, it can be modified. Um, at the same time, if the mail is resting on your device, and if that device is compromised, still the mail can be modified. But there are ways by which you can encrypt it and sign the email. So if there is any modification, you will understand. So these are some of the common weaknesses, and we are going to speak more on this going ahead. So as now we understood the weakness, now where is the solution? So this is where the solution lies. You put up something called a MSA. Now you saw what is MTA and you saw what is MUA, but MSA is something which is new over here. So now when Bob sends an email to Alice, the mail actually goes and stops at MSA. Now MSA will check. The MSA is basically mail security agent. It can be any email security solution that you have on at your premise or on your cloud, which will inspect the email, check the headers, check the attachments and the hyperlinks, and all many other things in your email to identify if the email is spoofed, if it is malicious, if it can harm the user, and it will do the actions accordingly as you have set over there. So if you want a spoofed email to be quarantined, it will quarantine it. If you want it to be rejected, it will reject it. So it adds all the intellectual which is required to identify the spoofed email or the malicious email. And once it is sure that the email is not malicious, it will send it to the MDA, wherein the user can access it at any time required. So this is the role of email security solution at a very high level. The current generation email security solution actually perform much more than this. But this is at a very high level. This is what it does. So it verifies if the email is spoofed or not. It sees if the attachments in the email are malicious or not, or if the hyperlinks in the email are malicious or not. And it also sanitizes your email. If there is a malicious attachment, the email security solutions are capable to flatten this attachments so that they are viewable, but at the same time, the links are not clickable. Or if there is a executable content, like for example, if there's a Excel which has a malicious script in it, a dynamic malicious script in it, like a macro enabled Excel. So the email security solutions are capable enough to identify these malicious scripts and remove them from the Excel, or convert the Excel into PDF and deliver, that the user will be able to see, but then the script would not execute. So we are going to look at the first two part, and we are going to see how you can do this manually, because many a time these emails, they get bypassed the email security solution. And I will explain you later when I will be showing you the advanced techniques which the hackers use to bypass the email security solution. Okay, so let's start with SPF and DKIM. Now this over here is a representation of SPF. Now we have the same scenario over here, and Bob is sending an email to Alice. Now what happens once Bob sends an email to Alice? If we have SPF configured, say Bob at karunya.edu is sending an email to Alice at karunya.edu, and if karunya.edu has a SPF record configured, the SPF record will look something like this over here, as highlighted above over here. Okay, so as you see over here, it says IPv4 1.1.1.1. So it basically says that 1.1.1 is authorized to send emails on behalf of karunya.edu. So when Alice receives the email, I've written MUI over here, but actually it would be at the upper level, at the server level, where it will check if the email is actually originating from 1.1.1. If the email, that is, if the SMTP server of the email sending the email was 1.1.1.1 as authorized by karunya.edu's SPF, the email will be delivered to the user. So it will be Alice will understand that this email originated from a server which is authorized to send emails on behalf of Karunya, and it will be delivered to the user's inbox. So this is how the sender's policy framework works. But what if suppose if the email is coming from 2.2.2.2? Now, when Alice requests for SPF, when Alice sees the SPF record, it will see that the authorized email server is 1.1.1.1 and not 2.2.2.2. So it will understand that this email is sent from a server which is not authorized to send emails on behalf of karunya.edu, which indicates that this email is actually a spoofed email. And that's how the SPF validation will fail, and Alice will understand that this is a spoofed email. So that's how the SPF works, and this is how the DKIM works. For DKIM, now with SPF, there are certain limitations. SPF can be bypassed if you know how. Sorry. So like I said, SPF can be bypassed if you know how. So basically, how SPF works is by validating the return path domain. So if the return path domain, if the return path domain matches the SMTP server as mentioned in the SPF record, then the SPF will pass. But if the attacker is smart enough, he can set a different return path domain and bypass the SPF. But DKIM cannot be bypassed because DKIM uses something called cryptography to um, identify spoofed emails. So basically how it works is karunya.edu will publish a public key over here. If you see the txt record, so there will be a txt record, something like this, which would be published by karunya.edu, which will have a public key over here. And all the emails will be signed with a private key. So when Alice now sends an email to, or say Bob is sending email to Alice, Alice will verify if the email was signed with the private key of karunya.edu. So if the email was signed by the private keys of karunya.edu, it will first, what will it will do, it will query the DNS server for the public key. It will get the public key and it will verify the signature. If the signature is valid, it understands that this email was sent by the SMTP servers of karunya.edu. I hope you guys have understood this is the basics of DKIM and SPF. Over and above this, there is DMARC, which I'm not covering in this topic, but just to give you an overview, DMARC is something which helps the organization to enforce the policies. So DMARC says what the SMTP server needs to do if the SPF fails and if the DKIM fails. And all the SMTP servers which are following DMARC follows the DMARC policy. And if say the DMARC says if SPF fails and DKIM fails, reject the email, the SMTP server will reject the email. So now we'll move ahead and do a practical example of SPF validation. So I have an email which I have in my inbox, and I'm going to check out the headers and identify the sender's IP address, and I'm going to validate the SPF record manually using something called as dig. So you can use the dig on your Linux machine, but I'm going to use this dig, which is available online from Google Apps. And finally, I will show you another tool on MX Toolbox by which you can manually, verify the SPF record in an automated manner. Okay. Now I have an email over here which was sent by one of my colleague who is working with this particular organization, ngtech.co.in, and he has sent me this email just because I requested him. Now, why I requested his email was to demonstrate the SPF validation. Now I'm going to see the headers of this email. To see the headers, what you can do is you can just do view message source and you will be able to see the headers. I'm going to copy this and use a tool like Notepad++, and I'm going to paste it over here. Now I'm going to dig online. And I'll type the domain that I want to verify. And I will look for the TXT records. Over here, I will see the SPF. This is the SPF record. So the V over here indicates the version. Include indicates that it has to include all the records mentioned over here and over here. And this thing over here is a syntax. So if you see this thing over here is a syntax which says fail. So when there's a hyphen, it says fail all. So include the records mentioned in these two domains and then it has to fail everything else. So if the email is arriving from this or this SMTP server, it will be accepted. It will be considered as pass. But if it comes from any other SMTP server, it will be considered as fail. Now you need to identify. So when you see the email header, all you can do is you can search for return path first. So that's how the SPF record is validated. If there is no return path, no return path which is set, what it will do is it will look up. You can look for SPF. Okay, you can look for this header. Now this header was set by the email security solution, which validated the SPF at the server level. And what it validated was it says SPF pass. Then it says domain of ngtech.co.in designates this particular address as permitted sender address. Now, if I look at this address was used to send the email. This address is of the SMTP server which initiated the email transfer. Now what I'm going to do is I'm going to go over here and I'm going to see the SPF record. Now what I'm going to do is I'm going to look for the SPF of this particular domain which is present over there. Now I'm going to look for this particular. Now I don't see the email, that is I don't see this particular email in anywhere over here. Now this is present somewhere over here deep inside. Now if you see, it says 209. So I'm going to see everything that starts with 209. Okay, now this is the network block /17. Yeah, so this is the network block which holds this particular server address. Now because this network block is permitted, anything sent from this particular server is also permitted. Now to verify it manually, it is, as you see, it requires you to manually go inside and investigate and check if the server is present in the included list. If it is simply present, if the SPF record would have been simply present over here, something like as mentioned over here, like over here as IPv4, and then the SMTP server IP address, it would have been very easy to identify. But in scenarios like this, what you can do is you can just copy this, go on MX Toolbox. Yeah, you can go on this particular domain on this tool and use the SPF record checker over here. All you have to do is you have to put in the IP address from which the email was sent, and you have to put in the domain name for which you need to verify. And I do a SPF record lookup. Now, when I do a SPF record lookup, it does all the calculations for me. And it says, it does all the calculations and investigation, and it says that the SPF record is valid. If you see over here, it says it gives a green color box. But if I change this IP address, say the email was sent from ngtech.co.in, but if it was sent from 1.1.1.1 instead of the SMTP server address that I had put over there, the SPF record will fail. Now it didn't match, and it indicates a SPF record failure. So through this particular record, I can understand that the email was sent from a server which is designated by ngtech.co.in to send emails. So this is how you can manually verify SPF if you are investigating a malicious email. And if the SPF record fails, you can identify that this particular email is actually not sent from the domain it is claiming to be from. And then secondly, the DKIM. So like I said, DKIM works with the cryptographic keys. And so the server which is sending me the email, I'll have to check on the DNS server, the public key, and I need to verify if the email is So in the email header, you will see the email signature. You will have to verify if the email was signed using the private key of the domain which it is claiming to be from. If sorry for that. If the verification passes, you understand that the same private key was used, which is owned by karunya.edu, and the private key is only with Karunya, so no one else can spoof it. So how you can identify this is you simply need to go. For this example, I'm going to look at the DKIM header. So I'm going to look at this particular header, DKIM signature, and I'm going to look at a few things over here. For example, the S over here, which indicates the selector, and selector is basically, it will tell the SMTP server that this is the domain, this is the subdomain at which the DKIM is hosted. And then I will have to look at the, I'll have to do a query with the SMTP server and identify the public key. Now I'll show it to you over here. Okay, so this is how the DKIM signature looks like. Over here is the version and the algorithm that was used for the signing. And this mentioned over here is relax. It can be simple. Relax. So this is just this just says that when you're computing, be relaxed, and if the header is modified, like if it is capital instead of small over here, it won't impact. But if it is present as simple, it will impact. So you can go in detail and you can look at this one. This is the most important thing that the SMTP server or the email security solution doing the verification will look at, the selector. And what it will do is it will do a DKIM, it will do a query with the SMTP server for identifying the public key. And once it identifies the public key, so let's try. So again, I'll go on DEG. So this is the syntax that you need to use. So the DKIM followed by domain key, and then whatever is present in the D section. D stands for domain. Now, this is the domain where the particular ngtech.co.in has hosted their private key, and from where the email was sent. This they are using Google Apps, and that's how it is. The private key is hosted with Google Apps SMTP, and the email was sent from this particular application, and this particular application holds the private key which has signed this email and computed this particular hash over here. Now, as you see, I can see the public key, which is hosted on the SMTP server. The email security solution can simply take this particular public key. It has all the required details present over here. Like, for example, the hash to be used and the algorithms to be used, and it can compute the hash and verify the DKIM signature. Now, to do this manually, you would not be able to do it. You'll have to run it through a program. You can use a program which is present over here. It's basically a script. So you'll have to first remove the unnecessary headers and pass it through the script. And if you get the same hash, you will understand that the DKIM, if you get the same signature, you'll understand that the DKIM signature is valid. But the easy way to identify this would be simply go in the header and look for DKIM signature, or just look for DKIM. And if you say pass, signature was verified, it means that the signature was verified. Now this is done at the receiving end, so it cannot be spoofed. Now, to summarize till now, we did a validation of SPF and DKIM, and we did it using the MX toolbox and DEG. Now, there are many other artifacts that you can look at in an email, like the sender's IP address. You can look at the domain name, which is sending you the email. You can look at the hyperlinks within the email, and you can look at the files and attachments in the email. We are going to do all of this one by one, and I'm going to show you all of this. So till now, you were able to identify the spoofed emails, but what if suppose the email is not spoofed, but actually the email is malicious? Now, the email SMTP servers, which are used for sending malicious email, if it's not a new server or not a server which is actually a genuine SMTP server but has been compromised recently, the IP address is usually blacklisted with many of the domain name blacklisting services. And using MX toolbox, you can actually check if the IP address is blacklisted. And further, you can do an analysis using something called virus total, using their graph API tool, and you will be able to identify and correlate this IP address and understand that this IP address has been used to send phishing emails or malicious emails. And then you can simply rate or increase the malicious rating of the email. So to check the sender's IP address, you can look for the sender's IP address over here, or you can simply get it from other places. Like now, in this particular scenario, over here, if you see over here, you should see the sender's IP address, but IPv6 address was used. But then when it is translated, it will translate to this particular IPv4. So I'm going to use this particular IPv4 for now. And what I'm going to investigate into this particular IPv4 address. And I'm going to go on blacklist, and I'm going to just put in the IP address, and I'm going to do a blacklist check. Okay, now it says that we have noticed that this particular IP address is on a blacklist by SOPS spam. And this particular IP address is of a public SMTP server, and that's how it is probably listed over here. But in most of the emails which are originating from genuine SMTP servers, you should not see it over here until and unless you are actually investigating into a malicious email. Now, I have certain malicious emails with me. Now, I have this malicious email which I'm going to open, and I'm going to investigate. So I'm going to see the IP address of the email server which is used over here. Now this is the sender's IP address, which I'm going to look at. Now, like I said, I know that I have verified that email as malicious, and but if you haven't verified and if you just put the IP address over here and do a blacklist check, you understand that that email SMTP server or the server from which the email originated has been sending spam emails, has been listed by many of the blacklist database maintainers. You can also look this on virus total. You can just put in the IP address over here, and it will tell you if it is malicious and it is related to malware. Further, you can click on this and you can get more details. Now, it says that this particular IP address has been seen on so many malicious emails. Now, these emails were probably sent from this particular IP address or this particular SMTP server. So it is not just you who is receiving it, but then many users have also received it. And this is what you can see over here. And if further, if you analyze, you will also identify that this IP address is hosting some HTTP page, which is probably a phishing page. So it says malware. So it may be hosting a malware, or probably it's a phishing page, but definitely it is something malicious. So this is what you can validate with the sender's IP address. And apart from that, you can just ignore this. Okay. Apart from that, if you see over here, this email was actually sent from the domain of USA.com. Now, if I see the from over here, you see it is sent from this particular user, at USA.com. So USA.com is actually the domain. And if I see the SPF over here, so I just search for SPF. Okay, there is no SPF record. Okay, there is no SPF record set, but there is a DKIM signature set, and the DKIM signature is for mail, but it is not verified. So probably it is injected, or it is signed, it is sent from a server for mail.com, but actually using the domain, spoofing the domain of USA.com. And further, if I go down, I see the return path, okay, set as USA.com. So hackers usually they set this USA.com as the return path, which is actually the senders as well, the from header as well. So if the SPF record is getting checked, it will get checked for this particular domain, and it will get passed if it is sent from a genuine SMTP server of USA.com. I go down and I see that there is a document which is base64 encoded right now in this particular EML file, but there is a document which is, as per the extension, it looks like a macro enabled document as per the extension and the content type. And this is what the email says. Now I'm going to open this email using something called as now this particular tool is used for sandboxing. It has many sandboxes hosted online, and you can just upload anything over here and you can investigate. Now I uploaded the email over here and I'm running it inside a sandbox. Now, when I open this email and I investigate on this particular sandbox, I will understand the connections. See, this is the actual email, if you see. So there is some text message in this email and says that there is an attachment which I need to look at. So I just take down this attachment, I place it on my desktop, and I open it. So anything on you do on this particular sandbox will get recorded. Now, if you see over here, there was a HTTP request sent, which is downloading exe. Okay. Now looks like there is something which is getting run on this system. There's something which is getting run on the system. So what it did was, in the backend, it downloaded this particular exe, that is clacks.exe, and it is doing something with the system on the back end. Now, once this particular analysis is complete, we'll be able to see what are the things it is actually doing in the system. Now, this is the domain it is communicating with. And this domain, if you see over here, has a rating of malicious. Okay, so I'll stop it. All right. Now I'll go on the details. I'll go on the process graph and see what happened exactly over here. Okay, so we started with Outlook. We opened an email which downloaded a Excel application. The Excel application downloaded this particular tool that says NTVDM. And if I get more info over here on this particular, okay, this is. Okay, so the Excel opened this, got this particular clacks.exe, and unfortunately, if you see over here, there was no response. So it did a query, but then it did not receive any response. But then I had run this tool previously with the same email, and it had actually downloaded. If you see, it had responded and it had downloaded that particular exe. Now, this is the hash of the exe which it had downloaded. And it says that it is made with made by this particular company or this particular tool. What I'm going to do is I'm just going to go on VirusTotal, and I'm going to take the hash from here. I'm going to copy it and I'm going to put it over here. Now, as per VirusTotal, this particular exe is malicious, and it has been detected by so many antiviruses. If I see the behavior, this particular exe identifies or touches many different components in the system, especially something like a CMD to execute commands maybe, and it even tries to hides itself behind processes. So this is the report from VirusTotal that you get just by running the hash to VirusTotal. So again, the very first indicator that we get over here that this particular attachment is malicious is this particular attachment is macro enabled attachment. It is communicating with a domain from which it is downloading a exe. So Excel opening, if I see the process graph now, so if you see Excel downloading a exe, this is something which is very suspicious. Excel should never download a exe from a third party website or from the internet. And this is the biggest flag that we have. Apart from the domain name and the SMTP server IP address from which the email was sent. So this is how you can verify the sender's IP address on MX Toolbox and VirusTotal, and you can run attachment on any run.any or VirusTotal, and you will be able to identify if the attachment is malicious and if the email is actually a malicious email. You can also do a lookup on this particular website of Cisco, Telos Intelligence, and I look up the domain from which it claims to be. So that's USA.com. Yeah, so it's USA.com. So on USA.com, I can get a whois of to with whom it is registered and when is it registered since. So it looks like it's actually not a malicious domain, but then maybe the user was compromised, or we'll have to look into it and see, because this particular email was actually sent using the SMTP server of mail.com and not. We'll have to verify if this particular domain uses the SMTP server of mail.com as said over here, or if it uses its own SMTP server and was just spoofed. If it uses the SMTP server of mail.com, there are possible chances. So if you see the authentication result over here is pass, which means that it is actually using the SMTP server of mail.com. So now there are chances that this particular email was compromised and was used to send the malicious email to other users. And okay, so sometimes when you click on email volume history, you will see huge volume of emails sent from this particular domain. Okay, you see the mail servers over here set to mail.com, so which means that this particular email is genuine. And sometimes when you look for domains over here, like I just look for gmail.com. Now you look for domains over there and you will see huge volume of data getting sent on this particular domain, and it gets tracked over here, and you can see every day the volume is like 5.4. I believe it is in millions. Okay, so if a domain is sending huge amount of emails every day, it is possibly the SMTP server which is used to send marketing emails or spam emails. So this is how you can verify with different tools the IP address and the domain name. And for the email hyperlinks, so say there is an email that you have that you are investigating and there's a hyperlink in the email. So you can look it on virustotal.com. So for the phishing emails, I'm going to go on a site called phishtank.com, wherein you get to search different phishing websites. I'm just going to do a fish search. I won't target it by brand, and I'm going to look for online sites which are valid fishes. Okay. It says it is valid. Looks like, so Chase is basically the Chase bank, and someone has created a phishing page of this particular website. What I'll try to do is I'll try to run this particular URL using a tool called urlscan.io. Now this particular tool will first check if the URL is reachable. Let's see this particular phishing website is still alive or still live. Many a times websites which are reported over here are taken down by the service providers immediately. But if this particular website is alive, we should be able to see it over here. So let's just watch. In the meantime, what will I do is I will just run this particular domain on virustotal.com and see. So it was tagged as malicious, and it is just created 6 months ago. So probably it is created for just sending phishing or just hosting phishing. Okay. Now this particular domain, though there was just one finding on the previous screen which said that this domain is malicious, you can actually see that this particular domain is hosting many different phishing pages. So it is actually, yeah, so it is actually still online, and the hackers have been very creative um, in developing this particular phishing page. It actually looks like the login screen for Chase Bank, and targeted to the users of Chase Bank. If you see the verdict over here, it says malicious, and it is 100. It has given the score of 100, which says that it is certain that the website is malicious. And there are a few more indicators from Google Safe Browsing that this particular website is malicious. This is how you can identify if the website is malicious, just by taking the link, and without opening it, you can just run it over here on urlscan.io, and you can get different artifacts from this particular email. So I just click on behavior, and I can see different things, like I can see the global variables which are set, and the categories by which it was categorized. It is categorized under phishing. It is rightly categorized actually. And I can also get the IOCs. Now, IOCs are basically indicator of compromises. If you further need to go ahead and block this particular hyperlink, you'll have to block these particular hashes. Now, most of the time, the hackers, what they do is they host images. Now, these hashes are usually for the images or the files which are hosted on the server. So this is how you can investigate into malicious hyperlinks, which you are not sure about, and if you see it in the email. So email security solution, they usually do all this work for you, and that is how the email security solution identifies the phishing or malicious email. So they check the hyperlink, they check the sender's domain name, they check the IP address, reputation. They see if how often do this domain name sends email to the organization users. And after all the analysis, it finally gives a verdict that this email is safe, or if it is not safe. If it is safe, based on the action that you have configured, it will deliver it to the user's inbox. But if it is not very sure, say if it is 50% sure, you always as an administrator will have an option to deliver it into their junk box or into a quarantine box. And when you're 100% sure, you can either send it to quarantine or just discard it. So, like I said, it will do a DKIM and SPF validation and DMARC validation as well. But since I have not covered DMARC, it also does a reputation check on the sender and a hyperlink check. So just as we did it, and it identifies if the email hyperlink is leading the user to a phishing page, if the domain to which the hyperlink is if it is malicious, and it will categorize the email as malicious. And finally, it also does a contextual email analysis, wherein what it sees is it sees this the keywords in the email. For example, at the signature or at the footer, if it sees this copyright 2020 at Microsoft and the sender's domain is microsoft.com, then it will give a tick mark that it is sent from Microsoft. The content is from the email content is from Microsoft.com, and the email is actually sent from Microsoft.com. So it will do certain contextual analysis. Now, what hackers do is they find it difficult to bypass the DKIM and SPF. They find it difficult to bypass the reputation or the hyperlink reputations. They find it very difficult to bypass all of this. But what they they see a scope over here to bypass the contextual email analysis, or to bypass the way in which email analyzes or gives a final verdict if the content of the email is actually malicious. And they come up with innovative techniques by which they can actually fool the computer system which is analyzing the email. So I'll go ahead and show you the advanced email bypass techniques. Now, the technique that we are speaking about, which is used by most of the hackers, and this technique was recently seen in 2019 and early 2000 and late 2018. But then it became popular in 2019. What it uses is it uses zero font or invisible fonts at times, but most of the times it has been seen as zero fonts. So, like I said, how email security solution works is it does a contextual analysis. It sees, say, in the footer, if it says 2020 Microsoft copyrighted, if it sees the keyword Microsoft, or if the word Microsoft in the signature, and the domain is microsoft.com, it will give a check mark that the email is actually sent from Microsoft. But say the email is not sent from microsoft.com, but if the signature says Microsoft, then the email security solution is sure that someone is trying to send content related to Microsoft, or trying to act like Microsoft, but is actually not sending from Microsoft. And this is how the hackers, they modify the text such that what you see over in the text would be something like this, Microsoft.com, but what the system will see is something like this. This is what the system will see, and it will not be able to understand that the text which is written is actually Microsoft.com. Now, I have an example that I have prepared. Now, there's an email which I have, I've written it in HTML, and it just looks very normal. And if I see the source code of this particular email, everything is very normal over here. If I look for the word Microsoft, okay, you see Microsoft account, you see Microsoft account team, just as you see over here. So for the email security solution, when it will analyze this particular HTML, it will also see Microsoft account team, it will also see Microsoft account. But when this particular hacker, or when this particular zero font technique is used, what we see is still this, but what the hackers, or what the system will see is this. So system won't see Microsoft. It will see something like MICR, then there is garbage text in between, and then there is OS, then again there is garbage text in between, and then OFT, then again garbage text in between. So Microsoft, I've split the word into different parts so that the email would not understand the security solution, which does the analysis of this HTML, will actually not understand that I have written Microsoft over here, or the visual representation of this text is Microsoft and not micro with garbage text in between. So this is the technique used in bypassing the advanced email filters. This technique is known as zero font attack. So as you saw over here, it is just scrambling the word, and it is mixing it with garbage text so to evade the filters. Another technique is called the punny code technique. Now, punny code is so there are certain languages which you cannot write it in using the ASCII characters, just as we write A, B, C, D, which are or 0, 1, 2, 3 in ASCII. We cannot write this particular alphabets in ASCII. And if you want to use this particular alphabets in ASCII, you need to use the Unicode characters. You need to put the Unicode characters into ASCII. Punycode is the representation of a Unicode character into a ASCII character. Now, what you see over here is Microsoft.net. Sorry. What you see over here is Microsoft.net, but it is actually not Microsoft.net. I will go ahead and show you what it exactly is. For the system, it will look something like this. Now, for a human eye, it looks like this, but for the system, it will look something like this. I'll show you how does this work. Now, I go on this particular tool. From IronGeek, and what I type over here is the domain that I'm targeting. And it will give me different representation in different Unicode characters that I can use to create the word Microsoft. Like, for example, I use this M I C. I use this R with a O S.
I didn't understand that.
F T. Okay, now this is the output that I have. Now, this particular output, if you see, when you read it, you'll read it as Microsoft, but I have actually not written Microsoft. But what I have written over here, is basically some, I have some Punycode characters. I have some Unicode characters which are getting converted into a Punycode. Now, this is the actual representation of this particular character. Now, this is not written in normal ASCII. It is written in a specific Unicode format, and I'm converting it to text, and this is how it will look like when I convert it to text. Now, you can buy a domain. I go on name.com. So I go on name.com for a domain search. And say you want to host a phishing website, which will be used for Microsoft phishing, and you want to host this particular website, Microsoft.net. Now, if you see, Microsoft.net is actually already registered. If you see, this website is actually registered with Microsoft.com. It is getting redirected to Microsoft.com. It is registered with Microsoft. But how can I buy this Microsoft.net over here? When I copy and paste this in a browser, though I am copying Microsoft.net, what you see, but when I'm pasting it, it will simply convert itself into the international data representation, or a representation of this Punycode into the text format. So this is what the Punycode will look like. So for you, it will look like Microsoft.net, but for the system, it will look like this. So this particular technique is called the Punycode technique, and this technique is used by hackers to illustrate that you are clicking on Microsoft.net link, but actually you would be clicking the this particular link. So this is what you see, and this is what the system sees, and this is how hackers, they bypass the email security solution. And finally, I'm going to speak about the base strike attack. Now, the base strike attack basically basically uses the base href tag. I'll show you how it works. But before that, let's see what is this. If you can identify what is this, you'll be able to block the attack. But none of us would be able to identify what this actually is. Now, even if I show you this, you still may not be able to identify what it actually is. But it is actually a assembly of a gun. When you assemble it together, it will turn into a gun. For a system, a gun may not be allowed, but this particular thing, when disassembled, this particular gun, when you disassemble it, it will just bypass the security solution. And this is the basic technique which is used by the hackers in base strike attack. So what they do is they divide the URL or the malicious link into two different components. Now, say mal.com/where is actually the malicious link. If you access where, or if you access mal.com, if you simply access them, you will not be able to identify that the link is malicious. So I have a code written over here in basestrike.html, and this is just a normal email, but what I've put over here is I've put a base URL in my header section. So base URL says notmalicious.com. And indeed, when you browse this particular URL directly, it won't be malicious. And in my hyperlinks, where I actually have the phishing, where I actually have the phishing links. Okay, I'll have to search. Okay, once more. Okay, so where I actually have the phishing link, I've just put payload, or I can just put anything else over here. I've just written payload. So if you browse this as http/payload, again, you won't be able to browse and the verdict will be not malicious. But what happens when you open this particular email and now when you see the link? Now, using the base URL technique, though this is mentioned as href, it will, when you click on it, it will redirect you to not malicious/payload, the complete URL, which will actually give you the malicious link. So for the email security solution, when it will do the analysis, it will see two different links which are not malicious. But when you click, you will see one link which is malicious. So this is how the base strike technique works. So these are some of the references that you can use to look more into zero font or punycode attack. I've also seen a few other techniques, but some of the innovative, I have one of the email over here. Now this particular email is not malicious by itself. If I open this, okay. Now, this particular email is not malicious by itself, but it has an attachment in it, which is actually malicious. So when the email security solution, it will see the email, it won't find anything suspicious or anything malicious, but it actually has to see the attachment. And in this attachment, there is another attachment which is malicious. So it is actually within an attachment, and inside that attachment, there's another attachment. So I've seen the hackers, they use different types of techniques. They try to be more and more innovative to bypass the email security solution. And this was just a few of the techniques. That is it. If you have any questions, you can ask me using the chat, or you can just come unmute yourself and you can ask me the questions.
Mr. Vivian.
Yes, sir.
That was a good presentation.
Thank
you.
you,
We
sir.
will ask the participants to ask their questions using your chat
Sure.
box, so that
Sure.
you can.
The students can just, if you have any question, you can post it in the chat box.
Maclean, I'm afraid of your virtual background.
தெரியல அது ஏதோ எப்படிதான் வருது.
Students, you can post your questions.
Radhika, you can post some questions to him. Even it was a wonderful session filled with more informations. Thank you.
Thank you. I hope it was knowledgeful and
Yeah.
everyone will benefit from it. Yeah, sure. I can. So there is Nitish Kumar who says if I can share the PPT document. Sure, I'll share it with Maclean sir. He can send it to everyone.